So this video is going to be about identifying any vertical asymptotes, horizontal asymptotes, and holes. The first thing that you should always try to identify from a function is the holes. So our function is 2x plus 1 over x minus 2. Now, to identify a hole, that is any common factor that divides out. Well, if you look, there aren't any common factors that can divide out, so I'm going to write none, because there are no any holes. Now for a vertical asymptote. In order to identify a vertical asymptote, it is when your denominator equals 0. It makes your function undefined. Right? So our denominator is x minus 2, so I'm going to look at that, and the value that makes x minus 2 0 is x equals 2. So once you have your factor, you can easily find your 0. All right? So we end up getting x equals 2. The next part is our horizontal asymptote. So really when we're looking at our functions right now, we're not going to think about slant asymptotes in these situations. We're going to look at whether it's bottom or it's equal. All right? When I say bottom or equal, I'm looking at the exponents. All right? If it is bottom heavy, the horizontal asymptote is going to be y equals 0. If it is equal, you're going to divide those coefficients. So I'm looking, it's x on the numerator and x in your denominator. So this is in a situation where it is equal. So we're going to divide our coefficients, and it's 2 over 1. So you can see that I'm just dividing the 2 divided by the 1, I get 2. All right, there's a couple of other things that I'm going to go over as well, and that's just finding our x-intercepts and our y-intercepts when we're working with these rational functions. All right, so remember, an x-intercept is when y equals 0. All right, so I'm going to set my function 2x plus 1 over x minus 2 equal to 0. Now, from there, we should recognize that the only time a fraction can equal 0 is if our numerator is 0. So if you start looking, you can see that I'm really just interested in that top piece, 2x plus 1 equals 0. Right? So really, when I solve that, I end up getting x equals negative 1/2. And I'm going to write that as an ordered pair. So x is equal to negative 1/2, while y is equal to 0. So there's my point, there's my x-intercept. Now for our y-intercept, we're going to set x equal to 0. I'm going to start plugging in 0 for my function for x, so 2 times 0 plus 1 is my numerator, 0 minus 2 is my denominator, and I'm going to go ahead and start figuring out what that equals, and it ends up getting negative 1/2. So my y-intercept is 0 comma negative 1/2. Right? So that's how you find your horizontals, your verticals, holes, which there aren't any, and then your x-intercept and your y-intercept when we're working with a rational function.